you. And I would like to thank each and every one of you for attending our February meeting for the White Bear Lake Conservation District. We do have some very interesting speakers tonight. I would like to call to order our quorum tonight. We do have a quorum, and I'd like to call it to order. And with that said, I would like to have an approval for the agenda. Is there any additions or deletions or subtractions to the agenda? All right, thank you.
So moved, Mr. Chair.
Second?
And all those in favor?
Aye.
Opposed? Motion passes. And then we do need to approve the minutes from last month's meetings. Is there any subtractions from that, those minutes from last meeting?
Move to approve.
Second?
All those in favor?
Aye.
Opposed? Motion passes. Okay, now we do have 15 minutes set aside for public comment time tonight. And I would like to at least advise you prior to the presentation with our USGS personnel here tonight, that if there is anything that you would like to address that is unrelated to what is on our agenda tonight, this would be the time to approach us. We are going to have comment time after the presentation, so if you do have questions in regards to the presentation and the information given by the USGS and their constituents, I would please ask you to wait until that time. But at this time, if there is anything in regards to unrelated agenda items, you could please approach the podium up here and address your name and your address, and we can go forward. Thank you. Sorry it's out of place, but yeah, it's fine.
Hi, my name is Kathleen McKee, 101 Wildwood Beach Road, Unit Number 4, Matamidi. Just a public comment. Approximately 2 weeks ago, there was a softball and ice tournament in front of Willerny Beach and also our residents, Wildwood Beach Manor. And I believe the board voted and approved their permit. But I'd just like to tell you that I picked up 2 bags of beer cans, trash everywhere, both on the lake, in Willerny Beach, and also on our road. And I just want you to know that. Thank you.
We thank you.
I'll follow up, Mr. Chair, because I don't think we approved a permit for softball and ice, so I'll follow up with Kate.
All right, thank you. And is there anything else unrelated to the agenda this evening? All right, thank you, and we'll move along here. We do have the new business, and with that said, I have a couple things I'd like to say before we get started with this here. And getting back to changing the agenda here, I would like to move the nomination of officers, Julie, down to 8E1, and at that time we can make the nomination up for our new officers. All right, and then I would like to just take a minute here to just at least thank all contributors, private donors, including municipalities, and especially the taxpayers who made this study with the USGS possible. I sincerely hope that some well-defined data and information will be provided to help the concerned parties understand the current condition and the future expectations of the White Bear Lake recovery. With that said, I would like to introduce from the USGS, Mr. Perry Jones. Thank you.
Thank you for allowing me to present our results tonight. I'd like to first recognize that we're here to present results from a one-year cooperative study looking at characterizing surface groundwater interactions in White Bear Lake. And I'd like to first recognize the fact that this was a cooperative study that involved a series of parties. The White Bear Conservation District was the lead in as far as the cooperative goes, but we had a set of state agencies as well as regional county. The counties participated, as well as the 4 cities around the lake. And we also had contributions from private organizations and from watershed organizations. And I'd like to thank them for helping out with the study. But I'd also like to thank the local residents, because a lot of them allowed access through their properties to the lake, allowed us to take water level measurements in their wells, and provided a lot of information as far as spring locations and other general information that helped us out in our study. So I'd like to thank them. Okay, so what's the issue? I think everyone knows what we've seen. Here's a plot of water level elevations for White Bear Lake from 1924 to the present. And as you can see, the water level has gone up and down, but what we've recently has occurred since 2003 is a drop in the water level to a historic low that happened in November of 2010. Since then, the water level's come up a little bit, it's come up about 1.5 feet, but now it's gone back down, and it's currently at a level that's about 0.6 above the record low that happened in November. And when we look at that record and compare it to our annual precip data for the area, we can see that there was a drop back in the late 1980s. That was due to a drought that occurred between 1988 and 90. And you can see that reflected in the drop in the rainfall that occurred. But when we do see that a similar drop that's occurred recently, we don't see what's happened as far as the precipitation goes. And so that led us to believe that maybe we need to look into more detail, see what's actually going on in the system. And when we looked in the area and looked at lake level changes, White Bear was not the only one experiencing some of these issues. And this was a slide I showed back about a year ago. And just to update that, what we've seen, here's some graphs. This is White Bear Lake from 2004 to the present. And you can see that's dropped and come back and then go back down a little bit. We see the same effect in Turtle Lake, in Shoreview. We see just down the road, Birch Lake, we see similar drop and then a rise. That's come back a little bit. But we also look and we can see some of the lakes to the northeast. We see Sunset and we see South School Section, that's dropped 9 feet. And Long and Round Lake. And so this isn't just a White Bear Lake issue. This is an issue that we've seen in other lakes across the area. So we were interested in looking at groundwater. And why are we looking at groundwater? It's because it's a major component into some of the lakes and supporting the lakes. And so what is groundwater? And so groundwater is basically the water that you find below the land surface that kind of totally fills in the openings in the underground rocks and the sediments. And so when you have a rainfall event, the water will fall on the land surface, and some of that falls off and goes over the land surface as runoff. But a lot of it, especially up in this area, will go and it'll start to seep in through the ground and come in as far as recharge. And the water will come down to a point until all the voids within that geologic material is saturated and filled. And that's what we call the groundwater. And another term we're going to be using quite a bit is the term aquifer. And basically, the aquifer is any type of material where you can actually put a well into the material and actually pump it for a water supply. It could be a domestic, it could be a municipal, it could be a variety of issues. And so when we look at a lake, you have to look at the different aspects of the lake. And White Bear Lake is different from, let's say, Bald Eagle and some other lakes because it's called a closed basin lake. And so what you don't see is you don't see rivers having water flow into it or water leaving through rivers. It's a closed basin system. And with that, you tend to see what are the water inputs to the system. So you can have rainfall as far as rain and snow that can contribute water, but you can also have groundwater flow that comes in and seeps into the lake bottoms or on the sides and provide water to the lake. And that can occur in fairly shallow aquifers. It can also occur in deeper aquifers and provide water up. But you also have output components. Water can leave the lake through evaporation off the water surface, but you can also have plants and grasses that are around the lake that take up water and then transpire the water to the atmosphere. But you can also have lake water that leaves the lake and flows into the groundwater. And with any lakes, you can have lakes that receive groundwater only, or you can have lakes that actually discharge only to the groundwater system, or what's more common is the combination where you have both, groundwater inflowing in one section of the lake and groundwater outflowing in another section. What complicates the issue is we have well pumping, which then can change some of these budget systems and change how much groundwater actually flows into a lake or how much leaves the lake. And those things have to be taken into account when you look at changes in the lake level stages. So to get an idea what the groundwater system looks like at White Bear Lake, I worked with Bob Tipping at the Minnesota Geological Survey, And we came up with a geologic cross-section that runs basically from Manitou Island Bridge down to Maunamii on the east. And this is the section we came up with. This is what lies right underneath White Bear Lake is glacial material, glacial till that was deposited when the glaciers advanced over the area. And there are different lobes that came across, so there's different types of till that's located there. But below the till, you find some of the aquifers that are used in the area quite heavily. And the St. Peter sandstone is one aquifer, but that tends not to be used very heavily in this area, although there are wells that are screened and that only take water from that aquifer. But the Prairie du Chien Jordan, the Prairie du Chien group and the Jordan sandstone make up one major aquifer that is heavily used in this area. And so there are wells that basically just take water from this aquifer. And so when we started this study out, we had a main objective, and that was to characterize the groundwater and surface water interactions in White Bear Lake. In other words, try to look at where water is leaving the lake and entering into the groundwater, the aquifers, or maybe where groundwater is flowing into the lake. And so we had a set of about 5 accomplishments that we'll list out. Is we did a historic look at the precipitation, groundwater, and lake levels, and did a comparison, look at the relationship, and try to get a feel for what may be controlling some of the factors as far as the lake level changes. We also did, working with the state agency, we did a groundwater level synoptic survey where we measured water levels throughout the watershed and throughout the larger region of White Bear Lake area to see how the water levels currently are at a various state. And then we did some localized looking at local springs by looking at temperature and mini piezometer and seepage meter surveys. And then we also worked with the University of Minnesota and did some lake coring work on the lake. And then we also did water quality surveys, including the EcoMapper, which was a water quality probe we sent through the lake system. And so I'm going to present the conclusions first so everyone knows and so you can see where we're going with. And what we've found is that the low lake levels, we found that it can be explained by a higher amount of regional pumping of the Prairie du Chien aquifer. But to a minor extent, it also can be explained by a lower amount of precipitation in the area. And we found that groundwater is flowing into the lake mainly from the glacial sediments that are on that upper aquifer. But what we see is lake water is flowing out of the lake and flowing into the groundwater, and it's reaching some of the wells that surround the lake in the Prairie du Chien Jordan and also in the glacial aquifers. And at this moment, we're going to talk about the historic relationships we looked at as far as lake level precipitation and groundwater levels. And I'd like to introduce Jared Trost, who's a hydrologist at our Water Science Center. And he did most of the analysis on this work. And so I'm going to have him discuss the results.
Thank you, Barry. So this graph you have seen already. It's a zoomed-in version of the hydrograph of White Bear Lake, or the water level through time, and also the rainfall, the precipitation, the annual precipitation totals. And this graph just goes for the period 1978 through the present. The reason being is that groundwater pumping to maintain the lake level ended in 1978. So we just focused on this time period, and the slides that I will show just focus on these 30-plus years. And so looking at this, again, as Perry mentioned, we see a decline in lake level in the late 80s, and we see a corresponding decline in precipitation totals for that same time period. So that lake level decline can be explained very well by the presence of the drought. Now we look at the present decline. It isn't declining as fast as in the late 80s, but we do see it is declining, but we don't see a significant drop in the rainfall, and so we wanted to look at that further. So what we did, we said, well, how does the present situation compare with the period 1978 through 2002? Is the lake changing differently in response to precipitation? So we divided this plot into year sections. So just looked at each year individually and basically looked at the change from January 1st through the through December 31st of each year. And when we do that, we get a plot that looks like this. And on this side, this is the annual lake level change. So that is the lake level on January 1st compared with the lake level on December 31st. And the zero line indicates that the two levels were the same, that the lake level over the course of that year didn't change. The net effect was that there was no change. The positive would indicate your lake level is higher. Negative indicates at the end of the year your lake level was lower than at the beginning of the year. And on this, on the x-axis, we have annual precipitation total. So basically you can see that as you get more rain, more snow, your lake level tends to increase more positively. Makes sense. A really wet year, you'd expect your lake level to increase. What we do see is that the recent time period from 2003 through 2011 tends to be much lower than previously. So something is different. This is, in fact, statistically significant. And basically, the annual lake level change is reduced by 1/2 foot at the same amount of precipitation. And on average, you're going to need about 4 inches more rain per year to maintain your lake level. And that's just looking at the relationship of annual lake level change versus precipitation. So a change exists. And so we wanted to look at that more closely and try and figure out what's going on. And so I should also point out that this was significant in the summer in particular. If we divide this out by season, we notice that in the summer and the other seasons weren't as important. And so it is well established that the White Bear Lake water level is highly dependent and highly correlated with the water level in the Prairie du Chien Jordan aquifer. And these dots here represent DNR observation wells completed in that aquifer in the vicinity of White Bear Lake. And White Bear Lake is right here. And what we can see, the blue line on this graph is White Bear Lake. And the green lines, well, the colored dots, the colored lines here are representative of those dots there. And you can see that White Bear Lake tends to track very well with the Prairie du Chien aquifer. You see the 1980s drought right here. You see a dip in the aquifer and a dip in the lake. And what you can see is that after 2003, many of these show a declining trend. And so the lake is responding to the aquifer. And I would also like to point out that after 2003, we see an increasing annual variability in these wells. You can see that there's a repeating pattern where the aquifer goes down and then comes back, goes down, comes back. And what we find is that those low levels are consistently observed in the summer months. And so we thought, well, what might be doing that? So we looked into the pumping trends. And so here is a record of the pumping, and this is maintained through the DNR's water appropriations process. This data we got through that database. And on this side, this is the annual pumpage in millions of gallons. And then this on the x-axis is time, is year. And what you can see is that the total withdrawals, the black dots, they are increasing. In fact, they've more than doubled since 1980. And you can see that most of that pumping is due to increases in municipal withdrawals. And the municipalities we included in this analysis are listed here. And furthermore, just breaking this out by percentages, in 1980, municipal pumping was about 65% of the total. And in 2010, municipal pumping was 85% of the total. And so if we break that out by aquifer, again, the black line is the total pumping in the area, and the gray line is that of the Prairie du Chien. You can see that most of this withdrawal is coming from the Prairie du Chien aquifer. In fact, 83% on average is coming from that aquifer. So municipal withdrawals from the Prairie du Chien are driving this trend. And furthermore, I don't have the graph shown, but the summer pumping is increasing most rapidly. And it comprises 40% of the annual total, just during the months of June, July, and August. So putting that all together, we see increased pumping in the summer. We see increased variabilities in the well due to low summer water levels. And we see the lake responding less to summer precipitation. It makes sense that pumping is having an effect on the lake. And so putting this all together then, we built a statistical model taking into account precipitation and pumping. And this is the actual observed data for White Bear Lake from 2003 through 2011, through the end of 2011. And our statistical model predicted these values on January 1st of each year. And this used the pumping data from 2003 through 2010. Now, if we do a little experiment and plug in the pumping from 1980 through 2002, plug in that average pumping over that time period, this is what we predicted that the lake level would do. And so, looking at that, you can see there's a difference there. And furthermore, you can see that even with reduced pumping, there is a decline in the lake level in recent years due to precipitation. So some of this is a precipitation effect. However, we see that much more of this response is driven by pumping, can be explained by pumping. And so with that, I will turn this back over to Perry, and he's going to talk about our synoptic well level survey.
Thanks, Jared. Okay, so to get an idea of what the regional water level pattern was looking like, we did two groundwater level synoptic surveys. And what's a groundwater level synoptic survey? Well, it's basically where we take a bunch of water level measurements in wells and also in lakes over a very short period of time. And I'm sure a lot of you, some of you people were actually involved in it, and you allowed us to take water level measurements in your wells. But we did two surveys. We did one between the end of March and the beginning of April, and another in August. And why we did the two surveys was to see March typically in April is a low pumping period. And so we tend not to use as much water from in the area. Whereas in August, when we have irrigations high and people take more showers and such, we have more pumping. We tend to have higher pumping rates. And so we took the two measurements so we can do a comparison to see what the difference was. And we measured water levels in 238 wells, and we measured water levels also in 66 lakes. And this was a cooperative effort. We had a lot of assistance and a lot of work with the state of Minnesota, with the DNR, the MPCA, and the Board of Water and Soil Resources, as well as the Met Council. And so what we wanted to get from these results was basically a regional pattern of groundwater levels for aquifers in the White Bear Lake area. And I'll show you results from two of the aquifers. One is in the glacial material in the upper aquifer, and then I'll show one of the Prairie du Chien Jordan, which is the one that's being pumped, and it's the lower aquifer. Okay, and what we're presenting here is basically what is called a potentiometric surface. And what it is basically it shows the pressure conditions and how they change in the aquifer over space. And you can compare this to something similar as a topographic map. If you've ever seen a topographic map that shows the high points where you have the hills, and then you have the low points in the valleys, well, it's the same concept, except it's with water. And so you see water flows from the high sections down to the low sections. And when we look at these contours, this is actually White Bear Lake here, and just for reference, here's Bald Eagle. But what we found in this upper aquifer, this is the Quaternary aquifer, we found that water tends to come from the east towards Sunset and Man Lake and down towards White Bear Lake. And then we also see in that upper aquifer water coming from the south down towards this city of White Bear Lake and up. And so, and then what we also found was that we saw lake water leaving the system and entering the aquifer and heading towards Bald Eagle. And that's based solely on the pressure conditions and what we see. And some evidence to show that we actually are seeing that is occurring is what we see at Mahtomedi Beach. And this is a photograph, maybe hard to see, but basically what we see on the beach, and if you've been there, you've seen them, probably seen them before and haven't recognized them maybe, but there are seeps, iron seeps. They're actually groundwater seeps, like springs that come out, and they're basically iron stained. And what is happening there is that groundwater that's coming up from the east is coming and actually discharging on the beach. And the groundwater has a lot of iron in it, and it's low in oxygen, so it holds the iron in as it travels along. Well, once it comes and discharges on the beach, it gets oxygenated. All the oxygen, the air comes in, and then what happens is the iron just falls right out. And so we see these seeps along here, and you can often see bright green vegetation associated with those, nice groundwater coming in. And so that was more evidence to us that what we were seeing might be true. But we also looked at water temperatures along the shorelines. And so what we had is the temperature probe that we took measurements from, and each of these dots represents a point where we took a measurement, basically every 100 feet along the shorelines. And what we wanted to see is it fairly uniform, the amount of groundwater coming in, or is there spots or spring spots where you see the groundwater preferential? And by looking at the temperature, where the cooler temperatures are, that's where we thought we'd see groundwater coming in. And so you see the light blue dots and the light green, those are areas here where we would tend to think we'd see groundwater coming in. And so to confirm that, what we did was you did something that's called seepage meter measurements at these locations. And what a seepage meter survey is, you picture a seepage meter, all it is a 55-gallon barrel drum, and you cut it in half. Then you take half, you actually stick it in the sediments, and here's a picture of one right here. And then we had a little hose that we hooked up to that, and then in a baggie we'd hook up to that. And you put this in, and you monitor how much water actually enters into these points over time. And so you can get an idea of how much groundwater flow may be leaving or how much lake water is actually leaving the system. And so we put them in transects, typically 2 to 3 at various locations. And we did that in May and August and September of this year. May, we kind of picked out sites based on what we heard from local residents, and those are in the red dots here. But we used our temperature data to do locations where we had the green dots to look and see where groundwater may be coming in. And this is results showing what we found in the August measurements. And the white dots here along the east shore generally were the values where we actually saw large flow rates coming in. And this represents, again, this fits into our model of groundwater coming from the east and discharging into the lake. And those are locations we found. But there are also 2 locations where we found up towards Ramsey County Beach where we had lake water leaving and going out into the system. And so that suggested, that may be lake water leaving and going into the glacial material and maybe heading towards Bald Eagle Lake. But what was a surprise to me, at least, was that we didn't find more of those sites along this site. So that indicated that, there's just not a lot of water probably leaving the system. Granted, we may have missed some locations here, but in general, we didn't see that much coming out. Now here's the potentiometric surface. Now we're talking about the lower aquifer. This is the Prairie du Chien Jordan aquifer. And what we see, here is White Bear Lake, Bald Eagle, here's Big Marine, to give you a reference. And the Prairie du Chien actually is fairly shallow here. This is actually the furthest extent to the north the Prairie du Chien comes in this aquifer. It just peters out. It's mostly down to the south. And so it's relatively shallow compared to most of the state as far as the Prairie du Chien goes. But what we see is that in between Big Marine and White Bear Lake is where we have the high. So you can picture at the hilltop, basically, of the aquifer, kind of where the pressure condition is. And then everything comes either to the west from there. But when we look at Bald Eagle Lake, White Bear Lake, we have water that kind of comes from that area and flows down in that direction. And then actually, instead of like with the glacial aquifers, which we had water flowing from the south flowing north, it actually keeps going towards the Mississippi River. This is a major aquifer system, and so it tends to flow towards the major rivers and river elements. And so we see water flowing in that direction. But when we look at the actual head pressures or the values of water flow, the White Bear Lake, when we took this measurement back in March, it was 920 feet, but when we look at the contour that actually goes right through the middle, it's about 910 feet. So if you picture it, the water level in White Bear Lake is about 920. The pressure condition in the aquifer is down here. So you don't tend to have water that's going to be pushing upward because the water level is down lower. And so we knew that there isn't water coming from this aquifer and coming up into the lake, but there's a potential for water to go the other direction. And so we also did some investigation into that. Now, the other thing is we wanted to look at the difference between March and August, high pumping versus low pumping. This is a plot of looking at the difference between the March and the March and the August values. And what we find is where we have the major declines, right along here, which is just south of White Bear Lake, which is right here, we see the major declines. We see as much as almost 12 feet of water level drop between March and August. And a lot of that probably is due to the impact of pumping. We also seen some declines up in the Hugo areas. They're not as significant, and we didn't have as high a density of wells in this area, so it may be just the artifact of one point or two, but we do see some declines. And the other thing to keep in mind is that if everyone remembers, this was August, and we took these measures after July, which had a lot of rain. We had a lot of rain last July, and so that may have an impact, more impact on the shallow aquifers, but since the Prairie du Chien is kind of shallow up in there, it may have some impact. So you might see some more larger declines when you have maybe a more normal precipitation period. So we go back to the water quality data that we collected, and what we looked at is we looked at general water chemistry, but I'm going to present some of the results we found with the stable isotope chemistry. And what's a stable isotope? Basically, an isotope is you have different forms, a heavy or a light form of a certain chemical element, say hydrogen or oxygen. There's heavier or lighter components. And in hydrology, we can use those differences between the two as kind of like a DNA fingerprinting. You can use that to identify where a source of water might be, or you can identify mixtures of different components of the water budget that may add to certain water samples. And so we often, what we do is we compare the heavy and light isotopes of hydrogen ratio versus the light and heavy of oxygen ratio. And why we look at hydrogen and oxygen? What's water? H2O. You know? And so we look at those differences to see what signatures we can find. And so this is some of the samples. We collected snow samples and rainwater samples last year and looked at those values. And these green dots here represent what we saw with the snow samples. And then these pink squares right up here represent what we saw in the rainwater samples that we collected. And they both tend to fall along a meteoric water line, that what we call a meteoric water line, which is basically the rain or the precipitation line for that. And this is actually a line we took from Princeton. That was done in a study by Matt Landon and others back in 1999. And so it really fit well with the curve we were looking at. But we also took water samples, surface water samples from the lake. And those are in the blue triangles here. And I'll show a little, and they're off that meteoric water line. And the reason why they're off that is because you have evaporation coming off the lake. And that makes it so that they fall off. And if we look at more detail, we can see that they actually seasonally vary along a line that we call the evaporation line. And all this may not seem so important, but when we compare this to what we see with the wells, it becomes more significant. So what we did was we collected water samples from a variety of wells around the lake. And some of them were in the shallow glacial aquifers. We had 5 wells here. Then we also looked at the St. Peter, which is a little further down, at 2 wells. And then we finally went to the Prairie du Chien. We sampled 7 wells, 2 to the east side and then 5 down to the south. And these were the results. So if we look back, again, this is that meteoric water line where the rain falls. And then these are our points for the surface water samples for White Bear Lake. And what we found is that if you look at the yellow dots, that's the St. Peter. They all cluster close to the meteoric water line. And if a well is getting mostly groundwater to most extent, they will tend to cluster around that meteoric water line because most of the groundwater receives recharge directly into the system. That water doesn't have a time to evaporate, so it doesn't fall off this line. But when we look at wells from the glacial and the Prairie du Chien, when we sampled, some fell pretty close to this water line, but others were distributed along a line that's kind of follows right along that evaporative line. And so looking at that from the standpoint, if we took a model, let's say a simulation, we just say all these values in here represent 100% groundwater. And then if we took an average value of the isotopes from all the ones from White Bear Lake, took an average and say that's 100% lake water, then what you can say is you can figure out a percentage of what components at each of these wells, what component is water from the lake and what water component could be from upgrading groundwater. And so when we look at that and we look at the samples we took, these dots indicate the blue represents the percentage of lake water, while the orange represents the percentage of groundwater. If we look at, for instance, this well we sampled on Manitou Island, we found that it basically had 80% lake water and 20% groundwater. And this is a well you have to understand now. The deepest part of White Bear Lake down here is 80 feet. This well is taking water that's down 180 feet. So you're seeing lake water down deep. If we look at some other wells over in here, we see 50% lake water, a lower percentage, maybe 20%. But again, remembering what we saw is groundwater may be coming up in this area and leaving towards that, lake water may be going in that direction a little bit. And I think that's what we see. In other places, we see it here to the south, we don't see any. But then we had groundwater coming in from the south heading in towards the lake in those shallow aquifers. Now if we look at the St. Peter sandstone, we only took 2 wells, but all groundwater. We didn't see any lake water in those wells. Now the Prairie du Chien was another source, and when we looked to the east, we didn't see any lake water in any of the samples. No signature that indicated lake water. However, we've seen one signature of a well really close to the lake that had 80%. Then we had some here, 50%. Some here close to 50, maybe like 48. Then we had some that only had 5%. And you look at this saying, well, it's a little different here. But then when you take into account those potentiometric surfaces, the direction of groundwater flow, it starts to make a little more sense. You can see from the east, remember the groundwater's coming in from the east in that aquifer down below. So there aren't very many big sources of surface water coming in. So that makes kind of sense. Okay, and then it flows through, goes under White Bear Lake, and then all of a sudden you start to see the lake water come into the system. And then and why is this one so low? Well, if you look at the contours, it would tend to flow this way. Your water's coming from here. It's not going under White Bear Lake. And so what we're seeing is that in these wells, we're seeing the presence or a signature that's indicating lake water that may be going in. And so to get a better picture of this kind of on a cross-sectional view, I'm going to do a cross-section down here and let you take a look and see what we think is happening. Okay, so if we look at these numbers represent the head conditions or the pressure conditions in the aquifer. And this is numbers for the glacial aquifers. And so from the west on the east side, we tend to have higher values. And so the water tends to flow from the high values to the low values. So that's why we're getting water that's coming into White Bear Lake. We picture that because White Bear Lake was 920. Now if we look at the pressure conditions down in this lower aquifer in the Prairie du Chien Jordan, we see it goes from 912 to 910 to 908. These are much lower values than what we see in White Bear Lake. But what we also see is that they tend to flow in this direction, from the east side to the west side. But what we think is happening is, once it goes under White Bear Lake, you get water that's coming in from the lake, it's getting down into this deeper aquifer, and then it flows down gradient, and then the well pumps, and you come out, and that's where we're seeing the percentage of lake water entering in. So what we see in this purple area is kind of a mix of lake and groundwater. Now we did some other work that kind of helps correlate some of the things we see. We did some work, we did some lake cores with the University of Minnesota LaCore facility, and we were looking at how thick the organic matter is. Because in a lake bottom, if you've got a large thickness of organic sediments, they tend to be low permeability, or they don't allow a lot of water through. So the thicker sediments you have, the less likelihood you have water going and leaving the system. And what we found, we only did one cross-section. We took one big core here, but we took a cross-section to see how thicknesses are. And we tend to find, over in the southwest, we found thicker sediments. They tended to range, about 10 to 15 feet thick. But when we get up towards the to the north, to the northeast, we had sections that were much shallower. We had only a 1.5 foot thickness, and it was pretty far out in the shore. So these indicate areas where maybe you've got more potential for seepage or downward leakage. The other thing is we took a lake core here, and at that location we had 7 feet thickness. Well, I talked with the people at the university, and they were pretty surprised because they say they would have expected a lot thicker organic sediments there. And the other thing they also saw were features, slumping features. If you picture like on the hillside, you see things slumped off the land surface. Well, they basically saw those same features down in here. And if you see this little feature here, it's almost like a little cave or a little hole that might be there, but it's filled in with lake sediments and glacial material. And so there's potential that that could be a site where you'd see downward flow of lake water into that lower aquifer. Now I want to include a couple slides of the EcoMapper because everyone was interested that we did the survey in July, in this past July. And what the EcoMapper is, basically it's a continuous multi-probe water quality probe that we have that has a GPS system that is like a little submarine. Everyone talks about the submarine. It went through the water, and we did surveys, a series of lines through these boxed areas. And we looked at a series of water quality parameters to see if we saw any differences that would indicate maybe some possibilities for seepage and outflow seepage. And this is just one example. This is actually a kind of a signature of the lake water temperatures. And what we found is that there are certain areas where you actually see some cooler temperatures and some warmer temperatures. And some of these cooler temperatures actually correlated with where we saw the seeps coming in. And so it kind of confirmed that, but this also provided some sites that we missed with cooler temperatures that may be other sites where we've got groundwater coming in. And so we have to investigate those a little further in the study. So basically, in conclusion, what we found, our main conclusions was that the low lake levels can be explained by some higher regional pumping conditions and lower precipitation. Jared presented that information, and it's a compelling thought as far as what's going on. Groundwater inflows into the lake are mainly from the glacial sediments. We're seeing it come in from the glacial sediments. We're not seeing water coming up from the bottom from that lower aquifer at all. But what we do see is lake water is flowing out, and it's actually reaching wells that are actually screened or cased into that Prairie du Chien Jordan aquifer and also in the glacial aquifers. So the question is, what can we do from here? What should we do from here? So what we'd like to do is, and we've talked with our counterparts in the state, we'd like to work with the MPCA, DNR, Met Council, as well as Department of Health, and we want to work with the counties and the city to address what are the big questions. This is one thing we came up with. How much water can we pump from the Prairie du Chien aquifer without we can pump from the aquifer without having minimal impact on the lake level, and B, having minimal lake water actually enter into the wells. And we also want to figure out, maybe not all the wells are causing the issue. Maybe there's certain wells that may be having more of an impact on a lake than another. And so what we'd like to do is try to address that. And we think by working together with the state and county, we can do a variety of things. The DNR has already indicated that they'd like to do further monitoring of the groundwater levels and seeing what's going on over time, and also try to help with identifying where the issues really lie. We can also employ groundwater flow models, and how we can do that is that we can do what are called optimization models. And what you can do is basically say, with the model you can say, I want to run a model that says, makes it so that we have very little change in the lake level. And then say, we need these wells in the system and we need to meet the demands of the water supply. Where can we come up with the best pumping scenario that would minimize the impact of pumping on the lakes? And we can run scenarios like that to try to figure out what's the best way to manage the water systems around the lakes. The other thing I think is that we only looked at a few wells for the stable isotopes. I think it's a really valuable tool, and I think there needs to be more work done because we only took one sample in each of these wells. These percentages of lake water could vary seasonally. You might have more in the spring, less in the spring, more in the summer. You think you might have more in the summer, but we don't know that. And so I would like to see this do some more work, and to do that with more wells. And so I'll leave you with that, and that's what we had to present. Are there any questions? I'll leave it up to the
All
board.
right,
Yeah, just a few?
first of all, I would like to ask the board members if they have any particular questions, and before I open it up to the public. And I do have a question myself here, and getting back to one of the slides that you did show us, it was about the decline and why it was so concentrated in those wells south of the lake. You said it was like 10 to 12 feet in the south and southeast area. And I don't remember exactly what slide it was, but it was the one that had the figures of the colored graphs on there.
Yep.
Why is it so concentrated in the south end of the lake right there?
Over here?
Well, the brown area where it declined
here.
10 to 12 feet. Yeah, why is it so concentrated in that particular area?
Well, you have to look at these two. You know, there's only a limited number of wells, but we have 2 wells here that show 11 foot and basically looks like 10 point, no, that's 11, another 11 foot drop. And a lot of those, there's some communities down there that are pumping water. And so, I mean, they could be drawing down enough water so that it has an impact. Now, these are static, so we waited until the water levels were allowed to recover in those wells, and we took those measurements. And that's where we see, but we see a variety of other wells where we see 6, 7, there's another 7, 6. And so there's a cluster that suggests that that's an area where you do see a drop in water levels.
City well there too, don't you?
Whose wells? Well, there's a variety of wells. There's the white, yeah, I know. You know, everyone wants the names. Everyone wants the answers. Well, I'll tell you what, you know, I can start listing out communities and stuff that are causing some of these issues.
Yeah.
But you know what? We still have other issues. We've got other lakes up here that are far from here that are seeing the same problem. So that tells me that you can point a finger at one community or one well, but I think it's a regional problem.
It's a combination of a lot of wells, I'm assuming.
That's right. And
It's
so,
not just a particular or two wells.
Yeah.
I would have to believe that.
because we have Turtle Lake over here that's seeing the same issues. We didn't get to monitor over
And-
there, but it's seeing the same problems.
And just real quickly, I guess I didn't really get the scope of the size of the Prairie du Chien aquifer and the Jordan aquifer. I mean, are we at the tip of it? It seems you said it kind of peters out farther to the north. I mean, how big is it to the south of us?
Well, I don't know if you saw, well, they didn't include it in that, but the Prairie du Chien Jordan aquifer, it goes through down to south to the border to Iowa, and then it actually goes down through Iowa into Missouri.
So it's a
It's a
large
regional
aquifer.
aquifer system, and we are at the top. We are towards the top in Minnesota.
Meaning the shallow?
It's shallow.
Shallow.
Yep. And the other thing to keep in mind is that aquifer also, the Prairie du Chien is a limestone, and it's a limestone that has karst features in it. So in other words, things like caves, sinkholes, and things like this. And so some of these features may be reflective of that on the lake's bottom.
All right, and are there any other questions from our board members?
I have one quick question.
Mr. Norwick, go ahead.
Could the recharge of the groundwater from the north be altered by development as well? Which would then cause some of the pumping to have even a greater impact. I know we've had development north of the lake and storm sewers and different improvements that were made. Is the recharging, since that's where the groundwater flows, have you identified anything there or looked at that at all?
Well, it could be, and we haven't looked specifically at that. But you could have, for instance, wells that are pumping over here that could bring water that used to go into White Bear Lake that doesn't, or goes in a different direction. But the thing is also, you have to realize that, again, a lot of those lakes that we're seeing that were dropping were up towards that northeast area. And so I think you could have the impacts of that's going on. But I think it's a regional issue.
Is, you know,
Mr.
there was
Saint Germain.
concern about the construction sewer line with the amount of water they pumped on.
Yeah.
Are we eliminating that now from a concern, or could that still be a factor?
Well, I guess you'd have to say to
It's up in
yourself,
that area.
it's right up here. This, right, it was in between Bald Eagle and White Bear Lake. I don't know if everyone's familiar with that, but there was a construction project up here where they had to dewater a lot of water. And when we actually looked at the dewatering rates for those pumping, and I believe it was 95 million and 96 million. There were 2 wells. But you've seen that, that's a lot of water. But there's some municipal wells that are in this area that are pumping just that amount. That was only for one period. And then these municipal wells are pumping all the time, every year, that amount. And to think that this pipeline is causing problems in all these lakes to the north, as well as down in here, it's hard to fathom that pipeline would do that. Plus, when we looked at the seepage rates up in here into the glacial material, we only saw we didn't see very high rates. It's a fine sand that's up in here in the glacial material. And so I don't think that's where we're seeing a lot of the outflow.
All right, and do you have some questions, Kevin?
I had one, thank you. Earlier you mentioned that we're running at about a 4-inch, we need about 4 inches more precipitation per year just to maintain
Yeah.
compared to, say, 20 years ago.
Mm-hmm.
Did you do any forward modeling to see what we would need for precipitation to bring the lake level back from where it is now?
No, we did not do that.
Okay.
That's a possibility. We could look at various scenarios to do that.
Mm-hmm.
What we did was a statistical analysis. You could also look at some of the pumping rates too, like Jared had shown in the graph, and you can incorporate some of that into that too, as far as reducing and pumping and how that may be impacting the system.
Yep.
I think a lot of that stuff, as you've well known, you could do with a groundwater flow model and do a decent job of estimating some of those factors. So.
Thank you.
And one more, Mr. Mashad, go ahead.
All right, we talked about that construction project and the dewatering that was done during the project itself.
Mhm.
One of the theories has also been that the water is following the pipe. And so has that been checked? I would like to get to a point where we can start checking a few theories off the list. And
Well, and if it was a shallow pipe, it was like 25,
30 feet.
30 feet
25,
down.
25 feet in the average.
And I thought if we had seen that, we would have seen that some of the near shore processes would have seen more water flow coming out through the system.
okay, so
So I really don't think that's the main cause. And plus, I still come back to the fact that we see the same issues in lakes far away from that. And it's hard for me to fathom. Now, did I go down into the actual sewer systems and actually look and try to monitor wells? No, I didn't.
Well, why not?
I had enough to do, I guess.
I ju-
No,
I ju-
it's,
I just thought there would be a reasonable way to measure whether or not there is a flow going along that pipe. I mean,
well, and it's a flow that's lake water leaving the system too that you have to look at.
right,
And we did monitor that.
so it's just not there right now.
We just don't see it
Okay,
now.
It-
Maybe
it's-
we missed it. Maybe it's happening further out. We did a lot of our stuff along the near shore, and maybe there's something further out. But since it was so shallow, I would have at least anticipated if it was such a major factor in causing the drop, I think you would have seen that in some of the values that
Okay.
we come up with.
All right, and I'd like to open it up to the public at this time, and we only have the one podium, so what I'm gonna ask is if over along our attorney over there, Mr. Cantor, there is a spare microphone, and if you do have questions, would you please approach that microphone and speak into that so the people out on television land there can hear what your questions are, and please state your name and your address if you would, please. Any questions from the audience? Please come up, sir, please go ahead. You just go ahead, here, we'll move that microphone over where you can get at it. Go ahead, move it over where you can get at it.
My name is Jim Drost. I live over just past Montemita. The questions I had, or I have two or three. One, is where you see seepage, does that area have bedrock under it, which is forcing the water into White Bear Lake?
Yeah, we looked at that. The bedrock is much deeper at that point, and we didn't see that at where the seepage points were. The other thing you've got to understand is there's a lot of glacial sediments, thickness there, and when you show the glacial sediments, they're not uniform. They're actually tills. And so you'll have areas where you have layers where you have sand, and then you'll have layers that are tight till material. And so there's a series of those down. We kind of showed simple variations of that, but it basically is that you can see sections within those glacial materials where you'll see sands and then tills. And a lot of times those tills where you see the springs will be where the till is underneath it, so that, like you mentioned, like similar to bedrock, but it's really more of in the glacial material where the water may be coming up and discharging.
But it's somewhat impervious.
Yes, there is sections that are definitely impervious. Yeah.
Then, where I'm located, our well is 180 foot down, but there's it was, I don't know that there is now because I haven't measured it for a while, there was 90 foot above the pump. But we're on hills and stuff, quite a bit above White Bear. And then on all of this, if you were to cut back on the water usage, I note, or at least I have been told, that Anoka County is now putting in meters on all the domestic homes. Now, is that something that they're just doing on their own, or has your research prompted that?
Not that I know of. Our research has been totally over in the White Bear Lake area, and I haven't had any of these results that really kind of have been used to show as far as metering. Not that I know of.
Okay. Now you're saying that we're on the end of the Prairie du Chien aquifer, and because of that, how rapidly is that going to rejuvenate if we continue to pull more and more water off? At some point, we're going to have to say, okay, you can't water your yard all summer long. You can't do this whether there's rain or not, because
Well-
we will have to recover that.
Yeah, that's correct. But it's not a decision that we're involved in.
Right, I understand.
That's why we get the DNR and others that are regulating water use.
But is there
We have representatives from the DNR here as well as the other agencies that kind of can address some of those issues.
Is there any calculation as to how much we'd have to cut back to recover this?
Well, and I think that comes back to we can do some of those calculations when we look at a regional aspects and involve a groundwater flow model and look at those aspects to see what kind of pumping rates do you really can keep to keep the lake levels up.
Okay, well,
Yep.
thank you.
And any further questions, please feel free to approach, go ahead. And trust me, there are no dumb questions, so if you have any questions whatsoever, now would be the time to ask them. Thank you.